Okay, we're just looking lastly at standard normal distributions, and this is when we use a Z table and we use a formula which is using finding a Z value. Now, before we used graphic calculators, we had to do all this probability work using these Z tables. So the important parts are a Z value is a standard deviation that's given here. You can see the normal curve on this table here. We have the normal curve. Instead of having a mean here in the middle, we have a zero value. And then as we move away from the zero value, we get, this would be the standard deviation, which we give a Z, the letter Z, and then the shaded area is our probability. So on the table here, the shaded area is all in the middle of the table. On the outside, the Z value is on the outside, and you look down first. So if my Z value is one standard deviation for my Z value, 1.00, you can see here next to it is the probability 0.34. So if I had a, now at the top here, this top little diagram, this is how we normally draw our diagrams, don't we? We have the mean in the middle, and then we have some other value, we call that the X value, that we want to find the probability perhaps to 415 grams from 380 grams. Okay. In a Z table here, if we have 0 and we're looking, let's say we want to find the Z value for the shaded area, and here it might be 30%. So 0.3 is what I'm looking for, or 0.30. What's the closest I can find to 0.30 in the middle of the table here? So I look in the middle of the table, I can see 0.3023. That's probably as close as I'll get. So then I go to the Z value here, 0.8. My Z value for 30% is 0.8, and then I also add on the 5 above. So you go across first, 0.8, and then 5 above is the Z value. Okay, let's find what about if I have a Z value of 0.42 is my Z value. What's the area? What's the probability for that? So 0.4 is here. So I'm going across. 0.42, I go down. That's my probability, is 0.1628. Now, how do we use these? This is what we'll look at next on the next page. So we'll start this one here. Sorry, I need to move that down, that off. Okay, there's my formula. There. Okay, so the problem I've got, kumaras are normally distributed with a standard deviation of 5 grams. 3% are below 30 grams in weight. What's the mean weight of the kumaras? So these are often excellence problems that are asking you to find the mean or the standard deviation. And we use this formula at the top of the page. The z value equals x, take away the mean, and then you divide that by the standard deviation. So in this problem, I'm told the standard deviation, I know my standard deviation equals 5, and I've got to find the z value. I'm looking for, what is the mean? So I'm trying to find the mean. I've got my standard deviation. My x value here will be the 30. X equals, actually it's a negative 30 this side. And my z value, now remember z values come from the mean, from the center of the graph. So I'm looking, I'll do it in blue, I'm looking for this area here, the center area. If 3% are below 30 grams, and this is 50% on the side, I must have 47% in the blue area. So my z value, I'm looking for, the area probability is 0.47. So I look on my table at 0.47 and find what's the z value. So the closest to 0.47 that I can see on my table in the middle is probably this one here, 0.4713. So I go across, my z value is 1.9, go up 0. So then I can put that in my formula at the top. 1.90 equals, my x is negative 30, take away my mean, which I'm trying to find, divided by 5. So I'm going to rearrange this, put my 5 on the other side. 1.9 times 5 equals negative 30 minus my mean, and you can just keep going to work out what your mean is. I've run out of room there, but that would be not too difficult to do. Okay, well, let's look at one more example of this on the next page. Okay, in this one, the time taken to solve a puzzle is normally distributed with a mean of 155 seconds. If 10% of students take more than 180 seconds, what's the standard deviation? Okay, so I have in the formula at the top here, I'm looking for the standard deviation here. I need to get a z value. So once again, the z value is this. You have to use that shaded area. I know that this area in here, that half of the graph is 50% of the graph, 10% is blue, so that must be 40% is red. I look on the table to the nearest value for 40%, so 0.40. I can come to, there's 0.4032, which, so my z value, look across, there's the z, is 1.3. 1.3 equals, this is my x, is 180 minus the mean, 155, divided by the standard deviation. So just rearranging that, standard deviation equals 25 divided by 1.3. On your calculator, work that one out. Okay, thank you.